All right, let's move on to question 3 on our free response. So question 3 is looking at sterling silver, which is a metal alloy, which is a combination of silver and other metals such as copper. So over time, it can tarnish, and for example, a chemical equation is shown below. So in question A, what are the oxidation numbers of silver in AgS versus Ag2S? So when you're studying for the AP exam, you should look at the rules for oxidation numbers and how to assign them. A lot of the rules are very similar to the ionic charge of the element, but there are some exceptions. So I'm going to just label all of them and then we'll fill in the answer below. So when I look at my chemical equation, silver, the solid, is it's an element, and elements have an oxidation number of 0. In my next compound, H2S, hydrogen, when it's bonded to a nonmetal, has an oxidation number of +1. And when hydrogen's bonded to a metal, it'll be -1. Now, the sulfur in this compound, what you guys have to remember is that the sum of the oxidation numbers must equal the overall charge on that compound. So for example, H2S it's a neutral compound, so there is no charge. So when I add up all my oxidation numbers, I need to get a sum of 0 for the H2S. And the hydrogen, well, it has a number of +1, but there's 2 of them. So altogether, that's going to be like a +2. And so what I know for the sulfur is that sulfur has to be -2 to get the sum to equal 0. Now, going on to the right side, hydrogen, the gas, is an element, so it has an oxidation number of 0. I know it's not asking me to do that one. I'm just going to do all of them because this is a helpful skill. For the silver sulfide, sulfur has an oxidation number of -2. And so the silver needs to add up to 0. So silver here will be +1. Okay, it's similar to the H2S one. And so my answers are silver, the metal, will be 0, and then silver in silver sulfide is +1. In the next question, I'm given the atomic radius in a table. Silver and copper, we see that they have a similar atomic radius of 165 and 145 pm respectively. So it says here, explain why sterling silver is better classified as a substitutional alloy rather than an interstitial alloy. This is a hard question in the sense of it's just something you have to study and review. So the definition of a substitutional alloy is one in which the metal ions that substitute one another are of a similar atomic size. So actually a good example of this is sterling silver, but if you do some research online, something like bronze, which is a combination of copper and tin, that's also a substitutional alloy because your two metal elements are similar sizes. And I'll just read you the definition here. It says here, because the substituting atoms occupy regular positions in the lattice, the overall structure and properties of the alloy tend to be similar to the original metal. So if we look at the AP answer key, they just say that in their answers, it doesn't have to be that detailed. They just say that they have a similar radius. Which makes them a substitutional alloy. That's the definition. Okay, in this question here, we'll do one more on this video part. Using the principles of atomic structure and Coulomb's law, explain why silver has a larger atomic radius than copper. There's many ways you can do this question. What I like to do is use the electron configuration. So if you've done quantum, that may seem familiar to you. So copper and silver so let's start with copper. I'm going to do the abbreviated electron configuration copper. I'll do the noble gas one. So its closest noble gas is argon, and then it will be a 4s2, 3d9. So I'm just showing like the quantum electron configuration. And then for the silver, it's going to be krypton. Krypton is the closest noble gas. And then it'll be a 5s2 and 5s2, 4d9. All right, so what I can see from these electron configurations is that silver has more orbitals. So if we look at these principal quantum numbers, Silver has 5 orbitals compared to copper, which has 4. So that explains why silver has a larger radius. So I'm just going to say silver has more orbitals, electron orbitals. Now, in terms of Coulomb's law, we should address that part as well. If I have more orbitals, what that means is my valence electrons in silver are farther away from the nucleus than copper. So why is that relevant? Well, my valence electrons in this element, valence, they're going to have a very weak nuclear attraction or Coulombic attraction. Coulombic attraction, which means that also contributes to its larger radius, because when your valence electron is not as attracted to the nucleus, you will be more, you're going to be more away from the nucleus. So there's not going to be as much of what we call a proton pull, where if the protons and valence electrons are very attracted, it's going to pull those electrons in, shrinking the radius. But if I don't have a very strong nuclear or Coulombic attraction, those electrons are going to be kind of puffed out a little bit more, and they will not be, that will also contribute to its larger radius. So hopefully that makes sense. And that's how we answer this part of question 3. So I'll pause it here and I'll go to the next video to answer the next question.